Hi guys, now we are going to discuss a problem make an AP given in the starter 217 contest. The problem states that we are given an array where each element is strictly increasing and our task is to insert possibly 0 elements into the array so that the final array that we have is in the form of an arithmetic progression. Let's try to understand the problem statement first. Let's say the given array is 1, 7 and 9 and this is not in the form of an arithmetic progression. So to make this into an arithmetic progression, we can add 2 elements, that is 3, 5, and the remaining elements will be as it is. If you can see, every pair of adjacent elements has a common difference of 2, which makes this final answer array as an arithmetic progression. That is what we wanted, and we need to return the minimum number of operations required to make an array as arithmetic progression. In this case, we inserted 2 elements, so this will be our answer. Okay, to understand the solution, first let's take only 2 elements, that is A1 and A2, and to make this array as an arithmetic progression, let's say we wanted to insert k elements into it in between the 2 elements. So the resulting final array that we have created will be A1 and all the new elements x1, x2, x3, so on until xk, as because we only inserted k elements, and the remaining elements will be as it is. So the resulting array that we have is an arithmetic progression, and let's call the common difference as D. If the final array is an arithmetic progression, we can derive one thing, and we can derive a relationship between the 2 elements A1 and A2. A2 is equal to A1 plus k plus 1 times of D. A1 is the first element, D is the common difference, and k is the number of elements that we inserted in between. As we inserted k elements here, the A2 is k plus 1th element, so we have taken k plus 1 here. From this formula, we can rearrange the formula as D is equal to A2 minus A1 by k plus 1. From this formula, we can state that D always divides A2 minus A1, as we are only dealing with integers. From this, we also see an observation that D is inversely proportional to K. That means if D increases, K decreases. If D decreases, K increases. And we know that K is the number of elements that we have inserted in between, and the problem statement asks us to minimize the number of operations needed. That is, we need to minimize the number of elements that we insert in between. That means we'll have to find a common difference D as large as possible, so that the number of insertions in between will be as low as possible. This applies to every pair of adjacent elements. That is, we can generalize this to A of I comma A of I plus 1. We can say that A of I plus 1 minus A of I should divided by the value D. From this, we know that the final difference, that is the common difference of the AP, must definitely be a divisor of each pair of adjacent elements in the elements array. That is, it should divide A2 minus A1, and it should divide A3 minus A2, so on until an minus an minus 1. The common difference should definitely divide every pair of adjacent differences, and we want to maximize the common difference. That means if we find the GCD of every pair, we will get a D value which is the maximum possible. GCD of A2 minus A1, A3 minus A2, so on until an minus 1. This will generate as the optimal common difference that we need. And now we are again stuck with another problem, that is we don't know how many elements that we need to insert between each pair of elements. Again, using this formula, we can derive the number of elements that we need to insert in between them. If we again rearrange the formula, k will be equal to A2 minus A1 by D minus 1. Is it? This will be the formula that is needed for the number of elements to be inserted between each adjacent numbers. We can generalize this to k is equal to a of I plus 1 minus a of I by the common difference D minus 1. Now we have both the values D as well as K. All we need to do now is iterate through the array, find the common difference once, and iterate through the array again, and find the number of elements that we need to insert in between each pair of elements. We sum all the values of k, and that will be our final answer. Hope you guys understand. Thank you.